다음 fixed time 프로그램을 다뤄보겠습니다. When the final time T2 is specified explicitly for non-autonomous systems, we can derive a necessary condition for optimal control by choosing T as a stating variable, similar to the approach in the maximum principle for non-autonomous systems. In this case, the transversality condition for the new state variable, that is time t, is unnecessary, since it has a fixed final value. By eliminating the corresponding equations, 슈프림 하면 이거 되고 슈프림은 we obtain theorem 6. Fix the time response. Let ut, t는 t1, t2, be non-admissible control for x dot equal fxx ut that transfers the state variable from xt1 to xt2, where t1, t2 are given. A necessary condition for ut and x to be optimal in the sense of more like this is that there exists a non-zero continuous vector for psi 0 t는 t1, t2 such that 했고 슈프림 했고 psi 0 constant는 non-negative, non-positive. where x0는 x0, x1, x는 r은 n 플러스 1부터 h5, h0 and psi 0도 n 플러스 1 벡터 or defined by 이렇게 되고 psi 0는 n 플러스 1부터 psi 0는 n 플러스 1 벡터. Equation 49 is sufficient if it is satisfied at an arbitrary time t1 is t2. No? Finally, let us consider the case where t2 is given is totally free. We can consider it as the case where the domain x2 spans the whole x space. Here, the transversality condition is as follows. Note that the psi 0 is a non-positive constant from theorem 6, equation 38 and 40. psi 0는 이렇고 psi 스타는 n 플러스 2 벡터 psi 0, x 스타는 이렇고 x 스타는 1이 되고 fn 플러스 psi 0는 n 플러스 x0, f0, f 스타 h0는 이렇고 x dot 스타는 이렇고 phi 스타는 이렇고 함일턴 form of dynamic equation. Psi star, psi 0는 observant variable vector. Psi star is a solution. Alpha psi star also a solution where alpha is positive constant. Therefore, without loss of generality, we can conclude that psi 0 minus 1. Theorem 7, fixed time and the free end state problems. Let ut t는 t1, t2 admissible control of x dot equal fx ut, where t1, t2, x t1 given x2 is free. And that's the condition for ut and xt to be optimal in the sense of like this is that there is non-zero continuous psi 0 t는 t1, t2 such that h0는 supreme u는 있고 psi 0 t2는 있고 이거 마이너스예요. Where psi 0 constant equal to minus 1. Example 4. In addition to the specified t2, now we assume free end state for example 3, namely xt1 and xt2 are given. x1, t1, xt2 are free. Equation 52. The equation theorem is right c0 minus psi 1 tangent psi 2 t2 0. Therefore, we obtain the solution by solving the four different equations: x1 dot x1, x1 with a boundary condition on xt1, x2, on t2. From the second equation 53. The third equation of equation 55, we have psi 1, t2 upon 부사인 또 제로고 부사인 원은 제로가 되고 부사인 투 도트는 되고 요거를 미방방식이 될 거고 요거는 이렇게 되고 요거는 이제 ln식으로 해가면 이거 c는 컨스탄트고 그래서 ln 없애면은 이렇게 되고 그 파사이 t2는 제로니까 c2 바가 0이져서 그래서 t2는 제로 되고 therefore from u가 2분의 부사인 55 도트는 t 이거 제로 이거는 되고 그리고 이렇게 하고 썬더드 해도 되고 이렇게 되고 The optimal trajectory of the state variable x1, 2 and x0 of 10 as follows 이렇게 되고 The result of ut equal 0 is not surprising. It is physically obvious. The input of a free endpoint problem with the cost function q becomes identically 0. 2-point boundary problem은 다음 동영상에서 보겠습니다. 감사합니다.